Last but not least, we have example number 3 for momentum. So we have at time t equals 0, a ball is struck at ground level and sent over level ground. That seems redundant for some reason. The momentum p versus time t during the flight is given by the figure with p naught, which is up here, is equal to 6 kilograms times meters per second, and P1, which is here, is equal to 4 kilograms times meters per second. At what initial angle is the ball launched? So at first glance, this seems like a very complicated problem. You're kind of like, I'm not given very much information, and how the heck am I supposed to find what initial angle this ball is launched at? However, it's actually a very simple problem because all we have to do is we have to remember that momentum, just like velocity, is a vector, and the momentum vector is going to be in the same direction as the velocity vector. So because of that, all we have to remember is that at the top of the ball's flight, so we can see that the momentum is decreasing, decreasing, decreasing. It gets to a minimum here, and then it increases again. And this is because that ball, maybe it's a baseball, it's hit, and then it's in a parabolic shape. As it is under the influence of gravity. And the reason that the momentum decreases and then increases is because the velocity is decreasing and increasing. So here we have an initial velocity, and then at the very top, we have our minimum velocity. So remember, at the top, all of that velocity is in the x direction. So really what we're getting here is we're getting the initial momentum that is in both the x and the y direction. It's two-dimensional. And then at the very top right here, we're getting the x component of the momentum vector, just like because we have all of our velocity in that x direction. So all we have to do here is we have to just draw our triangle. So again, that initial momentum vector is going to be the hypotenuse of our triangle. So P naught is equal to 6 kilograms times meters per second. And then again, at the very top of that parabolic shape of this object, we get that P1 because that's our minimum momentum of this flight. P1 is equal to 4 kilograms times meters per second. So all we have to do is use our trigonometry. We know this is the angle we want to find, and since P1 is adjacent to that angle, we're going to use inverse cosine. So we get the angle is equal to our inverse cosine of adjacent, 4 kilograms times meters per second, over hypotenuse, 6 kilograms times meters per second. And so here I get inverse cosine of 4 divided by 6, which is 48.2 degrees. And that's it.